In this video, we're going to be exploring molar mass. We will talk about how that applies to the mole concept and also use some calculations using Avogadro's number. So the average atomic mass on the periodic table, so for this carbon element, it would be 12.011 would be the average atomic mass. We're going to be using the average atomic masses to calculate molar mass. Molar mass is also known as formula mass. If you wanted to follow along in your OpenStax book, we're looking at Chapter 6, Section 1. So molar mass is the sum of all the atomic masses of the atoms represented in a chemical formula. So if you wanted to calculate molar mass, you first need a chemical formula. So we have some chemical formulas represented here. The first one is the chemical formula for water. So this symbol H is telling us that hydrogen is present in that compound of water. This symbol O is telling us that oxygen is also present. Now, the number that comes after each of these elements, the subscript that comes after each of these elements, tells us how many atoms of that element are present. So for instance, in H2O, since there's a number 2, a subscript of 2 after the hydrogen, that means there are 2 atoms of hydrogen in this compound. For oxygen, there is no number, no subscript after oxygen, so we assume it to be a 1, which means there's 1 atom of oxygen. The next example is copper 2 chloride, and we'll learn how to name these compounds in a later section. Right now, let's just look at the formulas and how to tell how many atoms of each element are present. So Cu is copper. There is no number, no subscript after the element symbol, so we assume there's just 1 copper atom. Cl is chlorine. The subscript of 2 tells us there are 2 chlorine atoms present in that molecule. The next example is C6H6. So we have carbon and we have hydrogen present in this compound. How many carbons? 6. How many hydrogens? Looking at the subscript tells me 6. So we're going to be using these chemical formulas to help us calculate the molar mass, along with the atomic mass that we can find on the periodic table. So let's look at how this is done. To calculate the molar mass of a compound, for each element present, you need to take the number of atoms, represented by the subscript in the chemical formula, and multiply it by the atomic mass, which you find on the periodic table. Then you add the molar masses of each element together. So looking at an example of CHCl3. So this is the chemical formula. I like to start by making a list of all elements present. So we have carbon, hydrogen, and chlorine. So I have my list of carbon, hydrogen, and chlorine. Next, I make a list of how many atoms are in each of those elements. And to figure out the number of atoms of each, we're looking at the subscripts. So carbon doesn't have a subscript after it, so we assume there's just 1 carbon atom. Hydrogen, same thing, 1 carbon atom. Now chlorine has a 3 after it. So that little number 3, that subscript, tells me there are 3 chlorine atoms. Now for the next column, we're looking at the atomic mass. And this is that average atomic mass that can be found on the periodic table. So when you find carbon on the periodic table, you'll see that its atomic mass is 12.01. For hydrogen, it is 1.008, and then chlorine is 35.45. Now you need to multiply across, so for carbon, there's 1 atom that has a mass of 12.01, hydrogen, 1 atom with a mass of 1.008, chlorine, there's 3 of them this time, so 3 times 35.45 gives us 106.35. Now for the total molar mass of that entire compound, we need to add the carbon to the hydrogen to the chlorine, and we get a total of 119.37, and the units are grams per mole. On the previous slide, we said the units when we calculate molar mass were grams per mole. Now, mole is a unit or a term that we haven't looked at yet in this course. We're going to look at the mole in Avogadro's number. So what exactly is a mole? A mole is the SI unit for the amount of a substance. So when we talked about SI units in Chapter 1, the International System of Units, the mole is the unit for the amount of a substance. This mole amount was devised by chemists so that they could count chemical particles simply by weighing them. And we define the mole using Avogadro's number. So Avogadro's number is 6.022 times 10 to the 23rd. So if we have 1 mole of a substance, any substance, it could be an element, a covalent compound, or an ionic compound. In that 1 mole, there's going to be 6.022 times 10 to the 23rd particles. So what do I mean by particles? Well, if I'm talking about an element, particles are going to be atoms. So elements, we said, are made up of atoms, and we can actually calculate, if we know how many moles we have, exactly how many atoms we have in a given sample. If we're talking about compounds, instead of the word atoms, we use the word molecules or formula units. The calculation is the same, Avogadro's number is the same, it's just the term used after it that is different. So why do we use moles? Well, atoms and molecules have a very small mass. They're very, very, very tiny. And it would be much easier to count large numbers of them doing a calculation than it would be to physically count them. I mean, look at Avogadro's number, for instance. 6.022 times 10 to the 23rd. It's written in scientific notation. It has a positive exponent. So that positive exponent of 23, that's saying you're going to move this decimal point 23 times to the right, making this a huge number. Now, would you want to physically count that many atoms? Well, first you'd need a powerful microscope, a lot of patience, and you would probably lose count several times before getting it correct. So instead of actually physically counting them, we use a calculation to figure out how many atoms are present in a particular sample. So how are we going to be doing these calculations? Well, we're going to do them in the same way that you would do calculations if you were using the term dozen. So what the term dozen means is 12 of something. It could be 12 eggs, 12 donuts, 12 pencils, basically 12 of anything. So you can use this word entities and replace it with whatever particular object you are talking about. So dozen means 12 in the same way that the word mole means 6.022 times 10 to the 23rd. It just looks scarier because it's such a large number. So if I were going to calculate how many eggs were in 3 dozen, to figure that out, I would take 3 and multiply it by what the word dozen means. And we just said dozen means 12. 3 times 12 tells me there are 36 eggs. Now, let's apply this using the term moles. So if I wanted to know how many atoms were in 3 moles, I'm going to do the same type of calculation. I'm going to take the number 3 and I'm going to multiply it by what the word moles means. And moles means 6.022 times 10 to the 23rd. So plugging that in and multiplying it out, we get 1.806 times 10 to the 24th atoms. Now, when we're calculating using Avogadro's number, the word entities can be atoms, molecules, or formula units. So here are the equations that you'll see on your equation sheet for doing conversions using molar mass as well as using Avogadro's number. So we have several different types of calculations we might come across when given word problems. One, going from grams to moles. So if you are asked to solve for the moles of something and you are given the mass and the molar mass, to solve you would take the mass in grams and divide it by the molar mass. Now remember, molar mass you will most likely need to calculate. The units on it are grams per mole. When you calculate the molar mass, you need the chemical formula and the periodic table. To calculate from moles to grams, given the mole amount, you're going to take the amount of moles given and multiply it by the molar mass. Next, let's look at some calculations using Avogadro's number. Now, how do you know when to use Avogadro's number? If you see the word atoms, molecules, or formula units at all in the question, one of these two equations will be used. So number of particles. When I say the word particles, what I mean is you're going to see either atoms in place of particles, molecules, or formula units. So if you're asked to solve for the number of atoms, molecules, or formula units, you're going to take the mole amount and multiply it by Avogadro's number. If you're asked to solve for the number of moles, you're going to take the number of atoms and divide it by Avogadro's number. We'll do a lot of these calculations during class period. Here's a flowchart summarizing those calculations. So those equations on the equation sheet that you saw on the previous slide help us go between mass in grams, to moles, and then to atoms or molecules. So if you're going from mass to moles, this direction, you're going to divide by the molar mass. If you're going from moles to mass, the opposite direction, you're going to multiply by the molar mass. In order to figure out the number of atoms or molecules, you need to have the mole amount. So how many moles? So given this moles amount, if you needed to figure out the number of atoms or molecules in that given substance, going this direction, you multiply by Avogadro's number. If you are given the atoms or molecules starting here, and they ask you to solve for the moles, you're going to go the opposite direction and divide by Avogadro's number.